Okay, so my suggestion with these questions is to pause the recording and do the question yourself. Okay, when you have the question done, then play the recording again and see are you correct. And if you have made an error, see where the error has happened. So it'll give you better value for these rather than just watching them through, because these are all off past papers and we have a limited number of past papers to go through. So this one, graph of the function f of x equals 3 to the power of x. Okay, so let's just talk our way through it. Okay, so that is an exponential function. Okay, because the x is in the index. Okay, so it's an exponential function. Okay, you're told because the x-axis is 0, 1 as shown in the diagram. Draw a graph of the function g of x equals 4x plus 1. Now, that's a linear function. Okay, and remember, for a straight line, you just need 2 points. Okay, so you can do your table and do a series of points if you like, but we don't need to do that. Okay, so let's just take the function g of x equals 4x plus 1. Okay, and let's take g of 0. So it's just obviously put in 0 plus 1, so we get 1. So the point is 0, 1. And let's take g of 1. So it's 4 times 1 plus 1, which is 5. So 1, 5. And just to be sure, we go to g of 2. 4 times 2. We don't need to do this. We could stick with 2 because we know it's linear, but we'll do this for the to be sure. And we have that. Okay. So now we're going to plot these points. So 0, 1 is here. 1, 5 is here. And 2, 9 is here. Okay. So we know it's linear. So we draw a line through. And we name it. Okay, this is the function g of x. Remember what we said the last day? We have to name these different, otherwise you get confused. So there's an f of x function, there's a g of x function. There you go. It's done. Right. Use substitution. Okay, to verify that f of x is less than g of x. So substitute means x is 1.9. So we have f of x is equal to 3 to the power of x. And g of x is equal to 4x plus 1. They've told you use substitution, so in other words, don't use the graph. So we're substituting in, instead of x, 1.9. So f of 1.9 is 3 to the power of 1.9. And we work that out and we get a value of 8.06. Okay, and g of 1.9 is 4 times 1.9 plus 1. And that's an answer of 8.6. So you're asked to show is f of x less than g of x, and we fill it in. So f of x is 8.06 less than 8.6, so therefore f of x is less than g of x. Okay, so comfortable enough. Yeah, but again, have the confidence that you're able to do these. Okay, so let's look at this one. Okay, so parts of the graph of the function h of x equals x, which is this one. So the highest power is 1, the index is 1, so it's a straight line. And k of x is x to the power of 3. So if you look at it, x to the power of 3, it has its 2 turns, okay? Right, it's 2 turns. Right, now, we're not, so it's a cubic. So we're interested, but that's all just interesting. It's nothing to do with the question. Find the coordinates of the points of the sections of the graphs of the two functions. Okay, so let's look at the points of intersection. Okay, so you have this one, you have this one, you have this one. So that'll look straightforward. You could find it from the graph, but the problem is they haven't given you any coordinates. So you can't find it from the graph, so we have to use algebra. Okay, so we're told that h of x is equal to k of x. Okay, so we know, all we know about h of x is that it's x, and all we know about k of x is that it's x cubed. Now, look at our equation, okay, because these are all linked to algebra, okay, so this equation is a cubic, okay, it has an x cubed in it. You would expect 3 solutions for a cubic, we refer back to the algebra, but anyway, we would expect 3 answers here, okay, so I'll rearrange that. So we have x cubed minus x equal to 0. Don't fall into the trap of cancelling. If you cancel, you turn it into a quadratic and you'll have 2 solutions. We want 3 solutions, okay. If you look at this now, okay, I'm going to factorize this through. Okay, so the functions is done, okay, by saying this is equal to this. Okay, coordinates are points of intersection. Okay, the functions are the same in those 3 points. Okay, that's why I was able to say this. Okay, so the coordinates of the point from the sector graph of the function is h of x equals to k of x. Okay, we get to here. Okay, we can take out the x squared minus 1 equal to 0. Now we have an x squared minus 1 here. We can very painfully use the minus b formula, but instead we should be able to factorize, and we'll come back to this when we're looking at the algebra. So I'm factorizing it, so I can get x equal to 0, or x minus 1 equal to 0, or x equals minus 1. Okay, now we're asked for the coordinates, so we need the y values as well. But if you look at it, okay, we have h of x equals x, which effectively is y is equal to x. So h is, so they're the same, so the coordinates x is 0, y is 0, x is minus 1, y is minus 1, this becomes x equals 1. So that's equal to x is 1, y is 1, and here x equals minus 1, y is equal to minus 1. And that makes sense from the graph if we write that. If we fill in our coordinates, minus 1, 1, minus 1, 1. Okay, there you go.